Hello, we're on 1.10 or 1.10 Algebra 2 notes today. They're on completing the square and vertex form. So you guys should have done this in algebra, doing vertex form and completing the square. We'll take it a little bit further, a little bit more challenging problems with larger coefficients in the front of x squared. But it'll be the same process. I want you to remember that you can use completing the square anytime you have a quadratic equation. Use completing the square. And it's used to solve a quadratic or put it in vertex form. Again, it's not used to factor. To solve a quadratic. And any quadratic equation will work with this. So if it has imaginary roots or irrational roots, where factoring only works with rational roots, quadratic formula and completing the square can work with any quadratic equation. All right, so the first one, the directions are to solve by completing the square. So I'm telling you the specific method I want you to use. Because again, you could use quadratic formula to do this one. This one's going to have irrational roots. Solve by completing the square. So it might say, leave your answer in simplest radical form. And again, that's a hint that it's not factorable, that you need to use quadratic formula or completing the square. So you have an option. So here's the original equation, and we want to solve that by completing the square. All right, so first of all, you cannot complete the square with a lead coefficient other than 1. So the lead coefficient must be 1. So if it's not 1, we need to get it to be a 1. So we're going to divide everything by 2. So now I have x squared plus 4x equals 1/2. All right, so now I want to make sure all my x terms are on one side. So x squared and x both have an x, so they're on the left side. So I want to make sure or get all the x's or all the variables on one side. Then we'll say the left side, but it really doesn't matter. And your constants on the right. So anything that doesn't have a variable is going to go to the right. So we already have that done. So we're going to move on to the next step now, because the 1/2 was already on the right. Now we're going to find our completing the square term. So this is like step number 1, step number 2, step number 3. So we're going to find b over 2 quantity squared. You have to memorize this completing the square formula here to find the term. I always say to be or not to. Maybe, I don't know, it's not a great way to remember it, but remember somehow b over 2 quantity squared. And you always want to use your new b. You guys aren't newbies at this anymore. So always use the new b. What do I mean by the new b? Well, here your b was 8, and now here your b is 4. This is your new b after you divided. So we're going to take 4 divided by 2, square it. That gives me 2 squared, which is 4. And we call this, I think Miss Locke coined the term, the b box. All right, so now I have that 4. So what I'm going to do is I'm going to take this x squared plus 4x and my 1/2, and I'm going to add that b over 2 quantity squared to both sides. So add b over 2 quantity squared to both sides. Okay, let me switch colors here. So plus 4 and plus 4. Next step is I want to convert the right side. Oh no, I want to convert the left side. Convert the left side to a squared to a perfect squared binomial. And combine the right side. All right, so this right here, I want to rewrite as a binomial squared. So to do that, I need to know my first term is x, what multiplies to 4 and adds to 4, and they have to have the same signs. Well, that would be positive 2. So whatever this number, to figure out what goes right here where this 2 is, it's going to be whatever this was before you squared it. So if it's a positive 2 here, it's a plus 2 here. If that had been negative 2, it'd be minus 2 here. Other way of thinking about it is you're really saying over here, x plus just b over 2 squared is your squared binomial. And then on this side, you want to combine. So put that into your calculator or get common denominators. But however you decide to do it, and always check it on your calculator, you must always use fractions. And that is so incredibly important because we want to be able to put this in simplest radical form. And you will not be able to do that if you use a decimal instead. All right, almost done here. I've got to go down to the next page here on mine. So step number 6, I'm now going to solve for x. So I'm going to take this, I'm going to rewrite this here. X plus 2 quantity squared equals 9 over 2. So I'm going to take the square root of both sides. So that leaves me with, when I square root something that's squared, I'm left with whatever is being squared. And then here, don't forget your plus or minus. I can't have a radical over a fraction, so I break it up into the square root of the top, square root of the bottom. And now I'm just going to do some simplifying. So the square root of 9 is 3. Uh-oh, I can't have a square root of 2. I can't have any radical in the denominator, so I multiply both the top and the bottom by radical 2. And I get plus or minus 3 rad 2 over 2. And my last step is to solve for x. So I'm going to subtract 2 from both sides. Always write the negative 2 first. So negative 2 plus or minus 3 rad 2 over 2. So those are my roots. And we kind of wrote out all the steps, so it took a little bit longer than it might normally. But if you need to, you have that to go back to now. Let's do another one, number 2. So solve by completing the square again. 2x squared minus 4x equals negative 5. All right, so we cannot complete the square. If you're feeling confident, if you remember this from algebra, go ahead and give this a try on your own. If not, I'm going to go through it again with you. So we can't complete the square if there's a number other than 1 in front of x squared. It's a 2, so I need to divide everything by 2, leaving me with x squared minus 2x. I'm going to leave a blank here, equals negative 5 over 2, blank. Now I need to have all my x's on one side and everything else on the right side. And again, this one was already set up like that. So I didn't have to subtract my 5 over to the right side. It was already there. But if the 5 had been on the left, you would want to bring it over to the right. All right, let's do our b box now. So we're going to take b over 2 quantity squared. You're going to use your new b, which is negative 2. You're not a newbie at this. And not your old b, which was negative 4. Right here, make sure you put that negative 1 in parentheses when you squared it. Otherwise, that is incorrect. All right, so we got positive 1. So now I'm going to take my 1 and add it to both sides. Next step, I'm going to take my trinomial here and write it as a perfect squared binomial. So I put my x down here and I take whatever this was before I squared it, so minus 1, or just take the middle term and divide it by 2. And then in my calculator, or using common denominators, so 2 over 2, I'm going to add these together and I get negative 3 over 2. Make sure that is a fraction. It will not work if it's a decimal. All right, now we're going to solve. So we're going to take the square root of both sides. We get x minus 1 equals plus or minus the square root of negative 3 over the square root of 2. And now let's just do some simplifying here. So I have a negative under the radical, so hopefully you imagine your arms straight out across, or my arms, or you're doing it right now with me, and then you pull them down to make the I, so you pull the negative out and make it into an I. And then we have another issue. We can't have a radical in the denominator, so we multiply both the top and the bottom by whatever that radical is in the denominator, leaving me with plus or minus I. Rad 3 times rad 2 gives me rad 6. Rad 2 times rad 2 is 2. And then lastly, I'm going to add my 1 over. So I get 1 plus or minus I rad 6 over 2. Okay. So next, we're going to talk about putting the quadratic into vertex form. So vertex form, again, something you should have seen in algebra, because I know that comes up on the Regents occasionally, is y equals a times the quantity x minus h squared plus k, where your vertex is your h and your k. So h is always the opposite sign of what's in there. K, since it's positive out here, is always your positive. Also remember from your parent functions that you talked about in algebra, this means we're going to shift it left, right, h, and then up or down k. All right, let's go through this together and we'll write out the steps again. So put y equals negative 4x squared minus 8x plus 1 into vertex form. Why would we want to put it into vertex form? Well, if you're looking for the vertex, it's much easier to be in vertex form. It's also easier to graph it in vertex form because we can easily find our shifts from our parent functions when we do that. Now, notice here there's a big difference between the first one we did as well. The first one you had equal to a number. So it was maybe equal to 0 at one point, or it was equal to 1 as how I gave it to you. Here we have a y in our equation. There's no y in number 1. In number 3, we now have a y, or I could have given it to you as f of x, same thing. They both mean y. So when you have a y, you can't just solve it unless you're putting in a 0 in for y. So it's asking you to find your x-intercepts. So for this, we can't just take the y out. So we have to keep it in there, but we're going to still do the same steps. So first step is I want to isolate the x squared and the x terms. Okay, so we want to move the constant to the other side. So I'm going to subtract the 1 because that does not have a variable on it at all. So I have y minus 1 equals negative 4x squared minus 8x. Next issue is that I can't complete the square if I have a number other than 1. So we need a lead coefficient of 1. So factor it out, whatever is there. So factor out the lead coefficient. You're not taking the GCF. You're factoring out whatever the number is in front of x squared if it isn't a 1. Okay, so this one is the coefficient, the number in front of x squared is a negative 4. That's not a 1, so I'm going to factor it out. So if I factor it out, I'm dividing each of these by negative 4, writing it out in the front, leaving me with positive x squared plus 2x. And I'm going to put in my blanks right here too. So y minus 1 blank. All right, next step. We're going to now do our B box. So we're going to do b over 2 quantity squared as our formula. We're going to use the new b again, so not the -8. We're using the +2. 2 over 2 is 1. So here, notice I don't have to put parentheses around my 1 when I square it because it's not negative. All right, so I'm going to take that 1 and I'm going to add it here. Now here's where it's really tricky and can get a little bit confusing. I'm adding it into here, but I'm not really just adding a 1. Because it's inside these parentheses that are being multiplied by a -4, I'm actually adding a -4 to that side of the equation. So whatever you put inside your parentheses, you need to check what you factored out for that coefficient and multiply it by that. So this would be, on this side, I have to actually subtract 4 because of that -4 times 1. Okay, so step number 4 is add the b over 2 quantity squared to both sides. And let's just make a note here that it's very tricky. It's a colon. Make sure you multiply by the number you factored out in step 2. So maybe star that, whatever you need to do to make sure, highlight it. Okay, so now we're just going to kind of simplify here. So on this left-hand side, I have -1 minus 4. So that's going to give me, let me write that out for you. And over here, I want to rewrite my trinomial as a perfect squared binomial. Again, so I take my variable, whatever this was before I squared it, so +1. Combine my like terms. And now I want to solve for y, so I'm going to add 5 to both sides. So I get y equals -4 times the quantity x plus 1 squared plus 5. And this right here is vertex form, set equal to y. To find my vertex, I take whatever is here attached with the x being added or subtracted, I take the opposite sign of that, and that will be the x coordinate of my vertex. And then the k value, I keep the sign that's on that. So my vertex here would be -1, 5. So you take the opposite sign inside the parentheses, and you keep the same sign. So that's for the h. And the k, same sign outside the parentheses. And that's your vertex. All right, so let's do another one here. So convert 6x squared minus 3x plus 1 equals f of x to vertex form and identify the vertex. All right, so first of all, I like to write it with the y or the f of x over here. So f of x equals 6x squared minus 3x plus 1. So the very first step, very important, is to get that 1, the constant, to the left side, to the other side. So we're going to subtract 1 from both sides because you don't want to factor, if you're going to factor out the 6, you don't want to do that from the 1. And you don't want to divide it by 6. So very important you do that before you do anything else. All right, and now we're going to factor out our lead coefficient, because in order to complete the square, the coefficient of x squared has to be 1. It's a 6, so I'm going to factor out a 6. Now notice 6 is not the GCF, so it's really important that you just take out the coefficient of 6. You're not taking out a GCF. So I take out a 6, so I'm dividing each of these by 6. So this one's going to be a little bit harder because I now have a fraction. So 3 over 6, I can reduce that to 1/2. And I put my blanks in as well. All right, so now it's time for our b box. So b over 2 quantity squared. I use my new b, so my new b is negative 1/2. And you can, again, type that right into your calculator, or you can do keep, change, flip. Keep the top, change division to multiplication, flip the denominator. So that's negative 1/4. I multiply straight across the top, straight across the bottom, which is 1 over 16. Big B box today. All right, so now I add in, always want to add into the parentheses first. So I add that 1 over 16. So over here, I didn't really just add 1 over 16. I really added 6 times 1 over 16. Since it's inside those parentheses, that's being multiplied by a 6. All right, so now you can reduce that. Again, if you need to use your calculator, just type 6 over 1 times 1 over 16, or 6 times 1 over 16, and that should give you 3/8. Take your trinomial and write it as a perfect squared binomial. So to do that, you want to take whatever this was before you squared it. That goes in here. So minus 1/4 quantity squared. Or take your b divided by 2, but that's a little bit harder here because you've already done it. Since it's fractions, I would just take that. Now in your calculator, combine your like terms. So you're going to type in negative 1 plus 3 over 8. Or you can get a common denominator of 8, which would be negative 8 over 8 minus, or plus 3 over 8 would give you negative 5 over 8. And then lastly, we want to put this in vertex form, so we're going to add the 5/8 over. So we get f of x equals 6 times the quantity x minus 1/4 squared plus 5 over 8. And then it asks for us to identify our vertex. So again, for your vertex, you're going inside the parentheses and take the opposite sign of the number in there. So it's a negative 1/4. We pull it out to become a positive 1/4. And then over here, the y coordinate stays the same sign. So that would be your vertex there. All right. So if you feel like you need a little more practice, I'm just going to give you a couple to try. So number 1, this one would be solved by completing the square. So again, actually, let me So let me just start you off on this one. You want to make sure you get all your x's together. So first thing you want to do is subtract over that negative 5. Or sorry, subtract over the positive 5 to get a negative 5. Then you want to divide everything by 2. You will have a fraction there with that negative 5. So I would pause the video here and check back for the answer. Okay, so your b over 2 quantity squared should have been 1. So you would add 1 to both sides. Your final answer should be negative 1 plus or minus I rad 6 over 2. And let's do one more. So the directions are put in vertex form. And identify the vertex. So y equals negative x squared plus 2x minus 30. So again, a little tricky here because the negative's out in the parentheses. So I would first start by distributing that negative in. So negative x squared minus 2x plus 30. And now do your process. So pause the video, try this one on your own, and then check back with me. All right, so you should have subtracted over your 30. I'm just going to kind of go through it fast, but I want to show you here that it's really important that you factored out your -1 because x squared has a 1 in front of it, but it's a -1. We can't have a -1. It has to be positive. So that would make it x squared plus 2x. And a lot of people forget to negate that other 1. And again, I'm going a little faster on this because I'm hopeful that you already did this on your own and you're just checking it with me. So here, your b over 2, you would use your new b, which is 2, and do your 2 over 2 quantity squared. So you should have had a 1 there, but you didn't really add a 1. You really added a -1. And then combine over here. So that's -30 minus 1 is -31. Rewrite it as a perfect squared binomial. And then subtract or add the 31 over. So I get -1x plus 1 quantity squared plus 31. Your vertex would be -131 for that one. And there's your vertex form. All right, that's it. I hope you guys are having a good day and you continue to. I hope that that makes sense and it seems like familiar to you from algebra. If you do have any questions at all, please let me know. And pie out.